Good afternoon, gentlemen. In this video, we're going to review area and volume using integration, but now we're going to be integrating by hand. If you'll remember when we did this earlier, after you set up the integral, you got to type it in the calculator. And again, now we are going to do this by hand. All right, so my first problem says find the area of the region bounded by f of x equals x squared plus 1 and y equals 5. Now, this is a graph that you are expected to know what it looks like without a calculator, okay? Now, f of x equals x squared is your standard parabola that goes through the origin, but if I put a plus 1 on it, then it is that same parabola shifted up 1, okay? So, that's sloppy. Give me a second. And that's what I wanted, but okay. All right. I just want to extend. Okay. So we have our basic parabola with vertex at 0, 1 as opposed to the origin. All right, and then I'm also going to use the line y equals 5, which is a horizontal line through 5. 1, 2, 3, 4, 5. All right, and so that is here. And when I say bounded, that's another way of saying enclosed by. So it's the region that gets enclosed or closed up, all right, by these two graphs. All right, now remember the idea of area. Or the idea of area and volume, right, is that you are technically, when you integrate, you're adding up an infinite number of rectangles, and so for area, we really need a length times a width, okay? You need a length times a width, and when you integrate, the width will always be your dx or your dy, depending on which way that you draw your length. If you draw your length vertically, then you will be working in x's. If you draw your length horizontally, you will be working in y's, okay? All right, now, when you draw your length, all right, you want to be able, like you need to physically think about, no matter where I draw it, okay, will I always be touching the same two curves, okay? And so if I draw it vertically, it doesn't really matter what quadrant I'm in, right or left, okay? If I draw it vertically, I will always be touching y equals 5 and y equals x squared plus 1, all right? And so to get my length, all right, I need to basically take the top function. It's always top minus bottom. So length is going to equal top minus bottom, all right? And so the top is the line y equals 5, and the bottom is the curve y equals x squared plus 1. All right, now you're welcome to simplify that before you bring it over here, or you can write it here and simplify it later. I'm going to choose to simplify it here. You do need to show your work when you do that. All right, and so I get negative x squared plus 4, or you can write it as 4 minus x squared if you would prefer, if you like that better. All right, and then the only other thing you need are the bounds, okay? Now, because we're working in x values, that means you need the x values of this region from the furthest to the left all the way to the furthest to the right, okay? So the furthest to the left would be whatever x value lines up here, and the furthest to the right would be whatever x value lines up here. So how do we find those? Because that is also something you will need to be able to find by hand, right? Well, it happens to be where those two graphs intersect each other, and since both are technically y equals, then I can set them equal to each other, and then I can solve. Well, this one's not too difficult to solve because you can get the x squared by itself and then use the square root to get x by itself. Just remember, you get plus and minus 2. So those are our bounds, okay? And then we're ready to integrate, all right? And so this is the part that's new, really, is that you have to literally take the integral yourself. So the integral of 4 is 4x. The integral of x squared requires the power rule. And then you need to plug in the bounds by hand as well. So let's see, 4 times 2 is 8. 2 cubed is 8, so that becomes 8/3. Then you subtract and plug in -2. Well, 4 times -2 is -8. -2 cubed is -8 times a -1/3 is positive 8/3. And then when you're combining this, I mean, you kind of need to see if you can combine things, you know, to make it a little bit easier on yourself. All right, so I can do the 8s. 8 minus -8 is really plus 8, so you get 16. And then -8/3 minus 8/3 is -16/3. And then it's just a matter of figuring out the common denominator of 3. It becomes 48. And 48 minus 16 is 32. All right, so my final answer is 32/3. Okay, now technically you could have done this problem a different way. You could have drawn your length horizontally. You could have, if you wanted to. The problem with that, though, the problem with that comes when you go to when you go to set up your integral, you have to work in y's. So if you draw your length horizontally, you have to work in y's, which means you have to solve for x. All right, so just want to show you what that would look like. All right, so I would take my equation y equals x squared plus 1, and I would get x squared by itself, and then I would take the square root, which is plus and minus, okay? And now you have to relate that to your picture, right? Well, the positive square root is going to be the right side, and the negative square root is going to be the left side. So you technically are touching two different functions because you've got the positive square root and the negative square root, all right? And when you go sideways, okay, when you go horizontal, the length is going to always be right minus left, okay? So if I go to set this up, all right, the right, I just said, was the positive square root, and then I'm going to subtract the negative square root, that's the left, okay? Right minus left, which I can combine in just a second, all right? And then because I've changed my variables to y, I need my bounds to be y values, which means I need to come back over here to my region and find the lowest y value and the highest y value, which is going to be 1 and 5, okay? And I will tell you that if you take the time to do a little bit of simplifying, all right, so square root plus square root gives you 2 square root, all right? There's the function you're going to integrate. This one would actually require u substitution, and that means you're going to have to change your bounds. So just for the practice, let me run through that. Because of the square root, this requires u substitution, where what's underneath is your u. Du would be 1 dy, since the variable is y, which means the 2 is extra. But that's a constant. I can factor that to the front, okay? So this becomes 2 times the integral of u to the 1/2 du, but I also have to change my bounds because I used u substitution. So for the top, when I plug in 5, 5 minus 1 is 4. And for the bottom bound, when I plug in 1, 1 minus 1 is 0. Okay? Now, I still have to integrate. I haven't integrated yet. So the 2 stays, add a power, divide by the new power, and then I will be plugging in my bounds. All right? Remember, because you changed the bounds, you're literally plugging them in place of u. Right? You never have to go back to the y minus 1. All right? So we have 4/3 times u to the 3/2. Well, remember that's the same thing as the square root cubed. So I'm going to plug in the 4, and I'm going to do the same thing, and I'm going to plug in the 0. Well, that one's easy, right? That goes away. All right? And the square root of 4 is 2. 2 cubed is 8. And 4/3 times 8 is 32/3. Well, it's the same region, so I better get the same area, okay? Now, sometimes you don't have the option of making a vertical length versus a horizontal. Sometimes there's only one way that will work, and you have to decide what that is, okay? So that is our review on area, okay? Now what I want to do is I want to take the same region, but I'm going to find a volume. So I'm going to pause the video just for a second so I can write down the problem, and then I will start recording again. All right, so we're going to be finding the volume of the solid generated when the same region, so I just redrew my picture again, same region is revolved or rotated around the line y equals 5, right? So you have to try to visualize it three-dimensionally. When I rotate or revolve, I make a circular motion, all right? But if I were to try to make that two-dimensional and flatten it out, all right, basically part of the parabola would get flipped up here, okay? So what you need to think to yourself is, if I were to shade that region in, would there be any open space? Like, am I going to get a disc or a washer? Okay, disc means there's no open gaps, right? If I were to literally flip this over here, there would be no empty space, okay? No empty space. So this is a disc, right? Which is essentially a circle, right? And so remember, volume is really just the area for a disc. It's the area of a circle, times a thickness, right? Because a disc is just it's like a, it's almost like a circle, but it has a little bit of thickness. And that thickness is going to be your dx or your dy, right? But it's that area of the circle that makes up the formula for the volume, okay? And so remember, let me give myself a little bit more space. The volume is going to come from integrating that area times the thickness. All right, an area of a circle is pi r squared, and the thickness is going to be dx or dy depending on what variable you're working in, and you do need bounds, okay? So for a disc, that is the formula for volume. All right, so now if we think about the circle, right, going through this shaded region here, then what we're revolving it around is the center. And so the radius has to touch the center and go out to an edge. Now you want to do it in the actual region that's given, okay? So your radius needs to go through the original given region. And it's just like finding the length. If it's vertical, it's top minus bottom. If for some reason you made it horizontal, it would be right minus left. So the radius here is going to be that 5 minus, all right, the function x squared plus 1, which we already know ends up being 4 minus x squared. So when I come over here and plug that in, I can factor the pi out. That usually makes it easier when I'm taking my integral. I need to put the 4 minus x squared in and square it, dx. And because I'm working in x's, I need the bounds, the x values of where the region starts and stops, which we already know is -2 and +2. Okay, well now I have to talk about, well, how the heck do I solve this by hand? Well, at first glance, you might think because it's raised to a power, you need u substitution. But if you did use u substitution, and the inside was the u, du would be -2x dx. And you can't compensate for a missing x. So u substitution isn't going to work, okay? So then how else will we do it? Well, hopefully you know how to square a binomial, right? You write it twice and FOIL it out, right? So we get 16 minus 4x squared minus 4x squared plus x to the 4th. And so we come over here, we simplify it and plug it all in. And it doesn't really matter what order you put them in, so maybe you want to switch the order and put the highest power first. Okay, like a normal trinomial. And now you are ready to integrate. Okay, now you are ready to integrate. All right, so just keep in mind that when you integrate, that pi is still on the outside. Power rule, constant rule, and then you're going to have to plug in your bounds. Okay, and unfortunately, you might have to do something like that by hand. Okay, it might happen. So let's see what we get. All right, so let's see. We have 1/5 times 2 to the 4th minus 8/3 times 2 cubed plus 16 times 2 minus, and then I'd have to do the same thing with -2. Well, -2 to the 4th is +16. Now, -2 cubed is -8. So that's going to change signs, and then that's going to be a -32. All right, when I work problems like this, I try to find like terms, okay? What did I do wrong? Oh, because I made a mistake in my power rule. That is not a 4th. That is a 5th. That matters very much so. All right, hopefully you caught that when you were watching it. So +2 to the 5th is -32, and -2 to the 5th is -32. Okay, there we go. Now it makes sense. So this becomes 32 over 5, and this becomes, when I distribute the negative, +32 over 5. So I can add them, and they already have a common denominator. All right, this is -64/3, and when I distribute, I get another -64/3, which gives me a -128/3. And then I've got a 32 minus a -32, which makes a +64. All right, then I will have to worry about getting common denominators. And so that's where I know the common denominator. I'm just running out of space. So I know the common denominator is going to be a 15. All right, but I have no idea what 64 times 3 is off the top of my head. I have no idea what 128 times 5 is off the top of my head. And I have no idea what 64 times 15, off the top of my head is. All right, so let's see. 3 times 4 is 12, carry the 1. 18, add 1 is 19. All right. 5 times 8 is 40, carry the 4. 5 times 2 is 10, add the 4, carry the 1, 640. And let's see, 20, carry the 2, 30, add the 2, placeholder, 960. And then, let's see, I've got a 960, a positive 192, a positive 960, and then I have to subtract a 640. So I get 512 over 15, and then I can attach the pi. Woo, and I'm finally done with my volume. Okay? All right, so I'm going to stop the video there, and I do have some other problems, so I'm going to record another video or two doing the washer method, reminding you of the washer method. We're going to do one that has a horizontal radius, and then we're going to refresh our memory on what to do if the region formed is the base of the solid and the cross sections are other shapes other than circles. Okay?